Acceleration due to freefall. When you drop two objects with the same weight from the same height, we're all aware that they will land at the same time. But did you know that if we were to drop two objects with different masses from the same height, they will also land at the same time? But why is this? Before we learn why this happens, we need to understand some key terms. Number 1. Gravity is defined as a natural force that attracts a smaller mass towards a larger mass through a gravitational pull. Number 2. Freefall is a falling of an object under the sole influence of gravity. And finally, acceleration is a rate of change of the speed of an object with respect to time. This leads to the scientific question, it being, why is the acceleration of two different masses the exact same in freefall? Before researching for this project, I was confident that the object with the heavier mass would land before the object with the lighter mass, resulting in different accelerations. Because it just makes sense that something as heavy as a rock would fall faster than a paperclip. To conclude this experiment, I will be dropping two objects with different masses from the same height and at the same time. I will then calculate the acceleration for the two objects and relate this back to the experiment. The materials that I will use for this experiment include a toy car and an action figure. And now it's time to see the experiment. Now that we have actually seen acceleration through the works from the experiment, we're now going to move on to the scientific reasoning behind this. To calculate the acceleration of the two objects, we need to first determine the overall force, which can be calculated by the force of gravity or the mass and gravity of the falling objects. Since we know the motion of falling is negative, mg will become negative mg. The mass of the action figure in the car is roughly 0.150 kg, which is then multiplied by the formula of gravity, 9.8 meters per second squared, to determine the net force, which is negative 1.47 newtons. Then using the overall net force of the two objects, we can solve for acceleration by multiplying the mass with the unknown acceleration. Then we can isolate for A by dividing the mass 0.150 kg by the net force, negative 1.47 newtons. To get negative 9.8 meters per second squared as the acceleration in freefall for the toy car and the figurine. Therefore, the acceleration is the same as gravity as the motion of falling is negative. Next, to calculate the acceleration for the other object, I will use the same formula to calculate the net force by plugging in the mass of the object, 0.020 kg, and the formula for gravity, 9.8 meters per second squared, to get negative 0.196 newtons. I will then plug in the net force into the acceleration formula and isolate for A by dividing 0.020 kg by negative 0.196 newtons to get negative 9.8 meters per second squared as the acceleration for the figurine. The results conclude that the acceleration due to freefall is not dependent on the mass of the object, as it is equivalent to gravity. Rather, the data may be affected as we cannot control air resistance, which will cause the car to accelerate faster than the figurine.